In September of 2021, astronomers made public their announcement that they had found a transient Earth Trojan asteroid. This asteroid followed the same path around the Sun as the Earth does in its orbit. This discovery was important because it marked the first time that a Trojan asteroid had been found temporarily sharing Earth's orbit with another celestial body. The discovery of a Trojan asteroid is extremely uncommon, but it has the potential to yield important information regarding the formation and development of the early solar system. Nevertheless, there are other objects in space besides Trojan asteroids that call for our attention. It is essential to detect and track near-Earth objects, NEOs, in order to prevent any potential impact on our planet from occurring. NEOs pose a threat to our planet. The term Earth Trojan asteroids refers to asteroids that travel around the Sun at the same distance as the Earth. They are separated into two groups, the leading group and the trailing group, and their names are taken from the Trojan warriors that appeared in Greek mythology. The group that is in front of the Earth by approximately 60 degrees is called the leading group, and the group that is behind the Earth by approximately 60 degrees is called the trailing group. The recently found transient Earth Trojan asteroid, which has been given the designation 2020 XL5, was a member of the group that was in the lead. Transient Earth, the discovery of Trojan asteroids, is extremely uncommon. However, doing so can yield important information regarding the origin and development of the solar system. It is believed that Trojan asteroids were left over from the process of planet formation when they first formed in the early stages of the solar system. They have been preserved in their stable orbits for billions of years, and they can provide clues about the conditions that existed during the early stages of the solar system because of this preservation. Asteroids and comets that pass within a distance of 30 million miles of the Earth's orbit around the Sun are considered to be NEOs. They are a potential risk to our planet, and it is imperative that we find a way to detect and monitor them so that we can mitigate any potential damage they may cause. Objects with a diameter of more than 140 meters are considered to be potentially hazardous objects, PHOs, which is one of the classifications for near-Earth objects, NEOs. The Near-Earth Object Observatories program at NASA is the organization in charge of locating and monitoring NEOs. Over 95% of all NEOs with diameters greater than 1 kilometer have been found, thanks to a program that searches for them using telescopes on the ground. On the other hand, smaller NEOs are more difficult to detect and keep track of, despite the fact that they are still capable of causing significant damage. The use of artificial intelligence is one of the many new technologies that NASA is constantly working to develop in order to improve the detection and tracking of NEOs. AI is being used by NASA to improve its capacity to detect and respond to threats in space, including near-Earth objects, NEOs. Because AI is able to analyze vast amounts of data more quickly and accurately than humans, it has the potential to become an extremely useful tool for detecting and tracking NEOs. NASA is using artificial intelligence to analyze data gathered from ground-based telescopes, satellites, and other sources in order to search for potentially hazardous NEOs and track their orbits. AI is being used by NASA's Center for Near-Earth Object Studies to predict the orbits of near-Earth objects and evaluate the level of danger they pose to Earth. CNEOS makes use of a tool known as Scout, which incorporates AI to perform data mining on information obtained from a variety of sources and generate predictions regarding the potential impact of NEOs. Scout is able to perform data analysis on information gathered from a number of telescopes and satellites, determine the path and speed of the NEO, and forecast both the location and time of any potential impact. NASA is leading the way in the development of cutting-edge technologies and strategies to detect and deflect near-Earth objects, which are objects in space that may pose a threat to Earth or other planets in our solar system. The organization is aware of the significance of these efforts in preventing potentially catastrophic impacts on Earth, and it is continuously working to improve its capabilities in this area. One mission that exemplifies NASA's commitment to reducing the impact of NEOs is known as the Double Asteroid Redirection Test, or DART for short. DART is a mission that will be launched in 2022 with the purpose of determining whether or not a kinetic impactor can successfully alter the trajectory of a NEO, The asteroid Didymos, which is accompanied by a more diminutive moonlet in orbit around it, is going to serve as the objective of this mission. DART will be able to gain valuable insights into the viability of kinetic impactors as a deflection strategy, if it deliberately collides with the moonlet at a high velocity. This will be accomplished by intentionally colliding with the moonlet at a high velocity. In addition to deflecting near-Earth objects, the DART mission has a number of other scientific goals as well. The impact will cause a measurable perturbation in the moonlet's orbit, which will enable scientists to investigate the changes that occur as a result of the motion of the moonlet. These data will contribute to our understanding of the internal structure and composition of asteroids, which is essential for the development of effective strategies for mitigating their effects. We will be able to refine our models and improve our ability to accurately predict the behavior of NEOs, if we gain new insights into the physical properties that NEOs possess. Nevertheless, identifying and following the paths of NEOs continues to be an essential part of reducing the threat that they pose. The Near-Earth Object Program of NASA has made significant strides forward in this domain by employing both ground-based telescopes and space-based observatories in order to search the sky for potentially hazardous objects. These efforts are coordinated and supported by the Near-Earth Object Observations (NEOO) program, which is managed by NASA's Planetary Defense Coordination Office (PDCO). This program's goal is to provide comprehensive coverage of the environment near Earth. The identification of smaller NEOs that have the potential to still cause significant damage upon impact presents a challenge. However, the smaller size of these objects, combined with their more suitable signatures, can make it more difficult to locate them. In order to address this issue, NASA is continuously working to enhance its detection methods by making use of cutting-edge technologies such as space-based infrared sensors and innovative approaches to data analysis. In addition, the agency works together with other international partners and members of the scientific community to improve the world's capabilities for detecting NEOs and to share important information. In addition, NASA is working on developing technologies that can deflect near-Earth objects. One such technology is the kinetic impactor, which will be tested during the proposed DART mission. The identification, tracking, and redirection of the near-Earth objects, NEOs, are critical components of an effective mitigation strategy for preventing potential impacts that could have catastrophic effects on life on Earth. As humankind moves forward in its exploration of the cosmos, it is imperative that we maintain a state of vigilance with regard to the detection and elimination of potential dangers in space. That's all for today. We hope that you liked the video. Please like, share, and subscribe to our channel for more videos like this.